shall start with a tutorial exercise and then we will go to introduction to computer-aided design of filters. So, the first problem is, this will be the problems that you have already gone through, similar problems. The input to a system is x n given by u n minus 4 and you have to determine the output. You are given the impulse response as minus 2 minus 2 1 1 1 1. Okay. So, this is the impulse response h n and you have to determine the output y n. Had it been u n, then it is a simple step. So, given an impulse response, how do you compute the step response? You keep on adding, that is integration. So, here it will be corresponding to u n. What will be the output y n if the input is u n? Output will be 1, then 2, this 1 plus 1, then 3, then 4, then 4 minus 2, 2, and then it will be 0. Okay. After that it will all be 0. So, it is magnitude, they are not to the scale 1, 2, 3, 4, 2, 0. Now, if I take u n minus 4 and if it is an LTI system, that is time invariant system, then it will be shifted by 4 steps. So, it will be finally 0 0 0 0, then 1 2 3 4 2, then 0. So, this will be the output. Okay. This is the output corresponding to an input of u n minus 4. All right. Next, the second example is something very interesting, half to the power n u n. This is x n and h n is equal to minus half to the power n u n. Okay. So, you are required to find out the output corresponding to, that is w n corresponding to x n plus h n, and also the output y n when x n is convolved with h n. Is that all right? Now, you can take these two signals together, w n will be half to the power n plus minus half to the power n u n. Okay. Obviously, when n is odd, they will get cancelled. So, this will be, when n is even, they will be same. So, 2 times half to the power n u n when n is even, equal to 0 when n is odd. Okay. One may similarly find out y n by taking the convolution. Okay. There is an alternative approach, take the Z transform. What do you get? If I take the Z transform, x z is 1 by 1 minus half z inverse, Hz will be 1 plus half z inverse. If you add them together, Wz is equal to half will get cancelled, 2 by 1 minus half z inverse into 1 plus half z inverse. Is that all right? And what about Yz? It will be product of the two, which will be just half of Wz. If you take the product, it will be 1 by 1 minus half z inverse into 1 plus half z inverse. Okay. So, it is half of this. So, Yn will be half of Wn. So, Wn you have already computed. So, without taking the convolution, you can straight away calculate from here Yn is equal to half of Wn is equal to half to the power n Un when n is even and equal to 0 when n is odd. Okay. Then the next question is, what would be the frequency plot of this? That is, we are required to determine this plot against omega and similarly W e to the power j omega. Since W is just twice the value of y, so the plots are identical, they are just scaled by a factor of 2. Okay. So, let me plot just one of them, y e to the power j omega. What is it? 1 minus half. Okay, let me write on this side the expression 1 by 1 minus x into 1 plus x. So, 1 minus half to the power 2, 1 by 4 z to the power minus 2 and z evaluated at e to the power j omega. Is that all right? So, 1 by 1 minus 1 by 4 e to the power minus j 2 omega. Okay. What are the two extreme values of this? One is 1 by 4 plus 1 by 4, the other one is minus 1 by 4. So, if I take plus 1 by 4, it will be 4 by 5. If I take minus 1 by 4, it will be 4 by 3. So, it will be starting with a value 4 by 3 when omega is 0, this is 1. So, 1 by 1 minus 4. So, 4 by 3 and it will be coming to a minimum value when this quantity becomes plus 1 by 4. So, it will be going like this and this minimum value is 4 by 5.8. So, 4 by 3 is this magnitude, 4 by 5 is this magnitude and it oscillates. What would be the frequency? Twice omega. So, it comes back again in this position after an angle of pi instead of 2 pi. Is that all right? So, this multiplied by 2 will be W. Next we have another question, Yn minus twice cos theta Yn minus 1 plus Yn minus 2 equal to sin theta into x n minus 1. Okay. What would be the impulse response h n corresponding to this difference equation? If you take z transform, this will be y z minus twice cos theta z inverse y z plus z to the power minus 2 y z, okay, equal to sin theta into z inverse into x z. So, y by x will be z inverse sin theta divided by 1 minus twice cos theta z inverse plus z to the power minus 2. Therefore, and this is h z. So, what would be h n? Inverse of this is our familiar expression sin n theta. Okay. So, this is the difference equation for sin n theta. Next, we have you are asked to calculate the step response for a causal system h z equal to 1 minus z cubed by 1 minus z to the power 4. Okay. 1 minus z cube by 1 minus z to the power 4. Now, if you look at this, one may write z cube minus 1 by z to the power 4 minus 1, and after that if I take z to the power 4 common, z to the power 4 common, then this will be z inverse 1 minus z to the power minus 3 by 1 minus z to the power minus 4. Correct me if I am wrong, is that all right? I have just taken z to the power 4 common here, z to the power 3 common here, and so that becomes z to the power minus 1 and this. Therefore, what would be the input if it is u n corresponding x z is 1 by 1 minus z inverse, is that all right? So, if I multiply output y z will be h z into x z. Okay. So, z to the power minus 1 into 1 minus z to the power minus 3 divided by 1 minus z to the power minus 4 into 1 minus z to the power minus 1. And that is equal to 1 minus z to the power minus 1 I can cancel here, it will be z to the power minus 1, I will be left with 1 plus z to the power minus 1 plus z to the power minus 2 by 1 minus z to the power minus 4. Okay. That gives me z to the power minus 1 plus z to the power minus 2 plus z to the power minus 3 divided by 1 minus z to the power minus 4. Is that all right? Now, let us compute from here what would be the response due to 1 minus z to the power minus 4. Whatever response we get, we will have 1 shift, 2 shifts and 3 shifts and add them together. Okay. So, corresponding to 1 by 1 minus z to the power minus 4, what will be z inverse of this? If you remember, earlier we had discussed in terms of the sequence, if you write straight in terms of the sequence, it will be 1, then 0, 0, 0, will it be minus 1 or plus 1? Again plus 1, because it is minus here, all right. Then again 0, 0, 0, is that all right? Again 1 and so on. Am I all right? Then if I have shifted, if I have this same sequence shifted by 1 step, 2 steps and 3 steps and add them together, so I will get the first shift will be 0 1 0 0 0 1 0 0 0 1 and so on, plus shift of 2 steps 0 0, then 1 0 0 0 1 0 0 0 1 and so on, plus this term with 3 shifts 1 2 3, 1 0 0 0 1 0 0 0 1 and so on. So, that finally gives me this plus this gives me 0, then 1 1 1, then again 0 1 1 1, again 0 and so on. So, this is the sequence. So, if I am permitted to write in terms of the sequence 0 1 1 1, then again 0 1 1 1 and so on, that will be the inverse of the original one, that is z inverse plus z to the power minus 2 plus z to the power minus 3. Okay. So, will be this sequence. If one wants to write in a closed form, that is instead of giving the sequence, that also you can write, what would be the expression for this? Z inverse of this W 4 n k summation k varying from 0 to 3, that will be equal to h n. Is that all right? Where W is e to the power minus j 2 pi by, if I write n, then it will be 2 pi by n. So, here it is 2 pi by 4, which is e to the power minus j pi by 2. Check whether you get the same result. Summation e to the power minus j pi by 2 into n into k, where k varies from 0 to 3, gives me e to the power minus j n pi by 2 plus e to the power minus j 2n pi by 2 plus e to the power minus j 3n pi by 2 plus e to the power minus j 4n pi by 2 means one. Okay. So, basically it is a multiple of 2 pi, all right. So, it will be 2 pi n, which is 1. So, it is 1 plus e to the power minus j n pi by 2 is minus pi by 2. So, minus j to the power n plus minus 1 to the power n plus j to the power n. Correct me if I am wrong, is that all right? Now, let us test it with some values whether we get this sequence or not. N is equal to 0, n is equal to 0 will give me 1 plus 1 plus 1 plus 1. So, there has to be a scaling factor 1 by 4, okay, 1 by 4. So, that gives me for n is equal to 0, therefore, h n becomes 1. When I put n is equal to 1, this is 1 minus j minus 1 plus j, it becomes 0. sorry, n is equal to 0, it is 1 1 1 1, n is equal to 2, this becomes 1, then minus 1 1, again minus 1, so again 0. H3, similarly H3 will also be 0, are you all getting that, and then H4 will become 1. So, we are getting this sequence. Okay. So, in a closed form, if you want to write just the analytical expression, not a sequence like this, what would be the mathematical expression for this sequence? For the main sequence it is this. So, this has to be shifted by 1 step, 2 steps and 3 steps and added together. Is that all right? So, it will be 1 by 4, therefore, actual Hn, overall Hn, I should write as 1 by 4 summation W4 n k, k varying from 0 to 3 plus summation W4 k equal to 0 to 3 n minus 1 k. Actually, this itself should be shifted. So, n minus 1, n minus 2, any question? I should multiply by un minus 1, un minus 2, is it not? So, let me write, this has to be multiplied by u n minus 1, this has to be multiplied by u n minus 2. Similarly, the third one W4 n minus 3 k u n minus 3. This is the overall sum. Is that all right? Next question, question number 5 is determine the value of x0 given xz equal to z by 3 into 2z minus 1, okay, z by 3 into 2z minus 1 plus z by 5 into z minus 2. All right. Determine the value of x0. All right. Determine the value of x0. So, I may write xz as 1 by, this is, if I take 3, if I take z common, okay, 2z common, what do I get? 1 minus 0.5 z inverse, is that all right? Z divided by, so z will go plus, similarly here 1 by, if I now take 5, 1 minus 2 z inverse, all right. This is a causal system. If you break it up, see how do you get the initial value? Z to the power minus 1, z to the power minus 2, they are all made 0, all right. That means z is made infinity, is that all right? So, if you put z is equal to infinity, do you get this? If I made z is equal to infinity, right here, this will become z by 6z. So, 1 by 6, 1 by 6 plus, similarly this becomes 1 by 5. Okay. So, that is 11 by 30, all right. See, xz you have written as x naught plus x1 into z inverse and so on. So, all these z inverse, z to the minus 2 etcetera are made 0, that means z inverse is made 0, z is made infinity. So, this will give you directly x naught. Next question is sketch the magnitude plot of Hz equal to 1 minus 2 z inverse divided by z inverse minus 2 and z magnitude is greater than 0.5. Okay. So, this 1 minus 2 z inverse by z inverse by 2, if I put z is equal to e to the power j omega, what do we get in the numerator? 1 minus 2 e to the power minus j omega divided by e to the power minus j omega minus 2. Take the real and imaginary parts. So, it will be 1 minus 2 cosine omega plus j sin omega 2 sin omega divided by cosine omega minus 2 minus j sin omega, all right. If I take the magnitude, it will be 1 minus 2 cosine omega square, 1 minus 2 cosine omega whole square plus 4 sin squared omega divided by 2 minus cosine omega whole square plus sin square omega, which gives me very interesting result 1. So, the magnitude in this case will be 1. Phase you can make out from here, tan inverse twice sin omega by 1 minus 2 cosine omega and tan inverse sin omega by 2 minus cosine omega, difference of the two. Now, this phase will be, you have to compute for 1 or 2 sample values, it will be again a periodic function. A filter which has such a characteristic, a flat again, is known as an all pass filter. So, basically it was an all pass filter. What is the peculiarity about the all pass filter? An all pass filter has poles and zeros in inverse positions, that is if there is a pole here at some distance a, then there will be a 0 at 1 by a, all right. So, poles and zeros are in inverse position. So, it will be appearing like this, say 1 by 1 minus a z inverse, then this one will be z inverse minus a. Function will be of this type. Okay. Next question is, a signal is given x t equal to 10 sin 2 pi into 50 t plus pi by 3 plus minus 10 cosine 2 pi into 75 t plus pi by 4 plus 15 sin 2 pi into 125 t, okay, and it is sampled at a frequency of 100 hertz, frequency of sampling. You are required to determine the period of the signal. How much is the period? All right. So, if you are given the sampling frequency Fs, that means the time sampling time is 1 by 100, that is 0.01 second, is it not? So, we can write xt as 2 pi into 50 into n times t, so 0.01 t. So, x n will become 10 sin 2 pi 50 into 0.01 n plus minus 10 of cosine 2 pi 75 into 0.01 n plus 15 sin 2 pi into 125 into 0.01 n. So, that gives me 10 sin 2 pi into how much is this? 0.5? 5 pi n. If I write 2 pi into something, then it will be 0.5 n minus 10 cosine 2 pi into 0.75 n, and then plus 15 sine of 2 pi into 1.25 n. Is it all right? Now, what is the period of these three discrete samples, these three discrete components? Period is, now what is the period of this? Period of this, first one I will call it T1 is 2, next one it can be 4 by 3, that is T2, and T3 4 by 5. So, you have to take the LCM of these three periods T1, T2, T3, which means LCM of 2, 4 and 4 and HCF of 3, 5 and 1. So, 1. Okay. So, that is equal to 4. So, period n is 4. Are you able to retain recover the frequencies from such sampled signals? What is the sampling frequency? 100 hertz. What are the frequencies present in the signal? 50, 75 and 125. All right. 125 is the frequency and your frequency of sampling is 100 hertz. You are sampling at a very slow rate. This is just meeting the requirement of that Nyquist criterion. Others, for other two signals, this is not meeting the requirement. So, you will have period t which does not reflect the signal that will be contained in, the components that will be contained in the signal. What should be, to recover the original signal, what should be the frequency of sampling? At least 250. Is that all right? So, can you try at home? If the sampling is at 250, what is the period? If the sampling rate is now 250 hertz, if the sampling rate Fs is made 250 hertz, what would be the period n for the same signal? Okay. Try at home and let me know. Next we had another question, determine the sequence Hn which will be the inverse DTFT, that is Fourier inverse of 1 plus 2 cosine omega plus 3 cosine 2 omega. Fourier inverse of this DTFT you are required to find out. So, let us see 1 plus 2 cosine omega plus 3 cosine 2 omega. I can write this as 1 plus twice cosine omega as e to the power j omega plus e to the power minus j omega plus 3 by 2 e to the power j 2 omega plus e to the power minus j 2 omega. For each e to the power j omega we put z, all right, then this will be 1 plus z plus z inverse plus 3 by 2 into z squared plus z to the power minus 2. So, we get a sequence 3 by 2 z to the power 2 plus z plus 1 plus z to the power minus 1 plus 3 by 2 z to the power minus 2. In the descending order of z I have written this. So, that gives me straight away the sequence as this is the one with z to the power 0. So, 1 before that, 1 before that, 3 by 2, then 1 and 3 by 2. Show the arrow, this is h 0. So, it will start with h n plus 2 which is 3 by 2, h n plus 1 which is 1, then h 0 has 1, h 1 has 1, sorry not h n plus 2, sorry h, how do I write, h minus 2, then h minus 1, then h 0, h 1, h 2. Okay. So, these are the values. Next, you are asked to design a very simple FIR filter . One 0.5 is the magnitude. As you know, for the FIR filter design, we calculate the expression for Hn we try to obtain by integrating it over a range of one period 2 pi from minus pi to plus pi. The given function as it is, because we will be providing a linear phase afterwards by just having a shift, and e to the power j omega n. In this case, if I produce it backward on the negative side, it will be symmetric. So, I will take it, I need to take only from minus pi by 2 to minus pi by 4 and then minus pi by 4 to plus pi by 4, then plus pi by 4 to plus pi by 2. Is it all right? So, I will take it this way, minus pi by 2 to minus pi by 4, it is 1 e to the power j omega n d omega, that will be half. Thank you very much. So, it will be 0.5, then minus pi by 4 to plus pi by 4, it is 1 into e to the power j omega n d omega. I will take then again 0.5 into e to the power j n omega d omega, it will be from pi by 4 to pi by 2. Is that all right? Now, you are asked to calculate a 9-point sequence, that is a length of 9. So, how many points should it be shifted by? So, I will compute whatever I presume, say the function, overall function after integration looks like this. Okay. So, I will compute h0, h1, h2, h3, h4, 4 on this side, 4 on this side, minus h minus 8, and h0 included, that will be total 9-point sequence, not 9 plus 9 and 1, all right. I do not want 19-point sequence. So, if the sequence length is given as a 9, normally we give odd numbers. So, that minus 1, the central one will be just ones, others are just mirror images. So, divided by 2 after subtracting 1, that gives you the number of points to be calculated. Put them on this side, symmetrical number, then give a shift. So, the new h0, I will call it h new, h1, h new 1, etc. New h0 will be old h minus 4, similarly old h minus 3, all right. H and 2 will be old h minus 2 and so on, and similarly new h and 8 will be old h 4. Is it all right? After you have obtained these, you have been asked to use Hamming window. So, window function, Hamming window function is given to you. All right, 0.46 plus 0.52, something like that, 54 cosine. Okay, it looks like this. So, there are values, these 9 values you have to take from here, multiply by these factors, these coefficients, that will be your actual realized window function, a realized filter function. So, I will get h n dashed 0, which is nothing but h n 0 into w 0, all right. Similarly, h n dashed 1 will be h n 1 into w 1. Is it all right? Now, we have just taken some varieties of problems for discussion. We will come to the computer aided design. So, before that, let me just describe in brief what are the structures that we have, what are the possible structures for realization of an FIR filter. Say, for an FIR, you are given a function h z, say h 0 plus h 1 z inverse and so on. I can always factorize this in the form of quadratics, all right. Say something like a 0 plus b 0 z inverse plus c 0 z to the power minus 2, a 1 plus b 1 z inverse plus c 1 z to the power minus 2, again a quadratic like this. One may go for quadratics. If it is an odd power, last one will be a linear function. Okay. What is the advantage? Let us see, if I take in a product form A0 plus B0 Z inverse plus C0 Z to the minus 2, what will it be like? I have a signal xn, I take a derivative z1, again derivative z to the, delay z to the minus 2, and then multiply it by B0, multiply this by C0, add them, just a small circle will be sufficient to denote an addition, and then A0. So, this gives me the output coming out of the first block. Again you have Z inverse B1, Z inverse C1, this is A1, and so on. So, for each quadratic we have such blocks, all right. In case now these parameters you are trying to finally represent by a finite register length, the memory is finite. So, there will be some truncation error, all right, but suppose any error in these coefficients, any of the coefficients will alter the roots of only these, that is roots associated only with this particular quadratic, it will not be affecting any other root, all right. So, we are trying to make the roots sensitivity restricted, roots coming out of this quadratic will be restricted, the sensitivity will be restricted to only these 3 parameters, all right. Similarly, for the second one the roots will be restricted to only these 3 parameters, if they change then only the roots will change. Had I had a realization like this H0, okay, H1, H2 and so on in a single shot, if I had all the elements together, mind you number of delay elements will be identical, all right. Only thing probably this will be, I mean this will be easier to implement, it might appear, okay, but then change in any of these will be affecting all the roots, okay. If any coefficient is affected then all the roots will be affected simultaneously. So, here the sensitivity can be restricted to only a limited number of parameters, limited number of coefficients by this realization. Okay. Similarly, in case of an Iir filter, I have Hz equal to say all right B0 plus B1 Z inverse plus B2 Z to the power minus 2 and so on, divided by A0 plus A1 Z inverse plus A2 Z to the power minus 2 and so on, polynomials both in numerator and denominator. I may express these in terms of biquads, okay. Say I will call it C, because I have used A and B terms, so I will write like this C0 k plus C1 k Z to the power minus 1 plus C2 k z to the power minus 2 divided by d 0 k plus d 1 k z to the power minus 1 plus d 2 k z to the power minus 2, okay, where k varies from 1 to say any number p. That means the number of such quadratic terms that we can get. It may so happen this is of lower degree, so you may not have all the coefficients present in a biquad. It can be just a constant divided by a quadratic. Now, in a biquad again, the poles and zeros corresponding to one biquad will be restricted, the sensitivity will be restricted to only these coefficients, these 6, not the entire set of numerator and denominator coefficients. Okay. So, quite often it is this biquad forms which are used for computer-aided design of an Iir filter. How is it done? The technique is very simple. One of the techniques is, so you have Hz equal to some constant into these quadratic coefficients C0k plus C1k z inverse plus C2k z to the power minus 2 by d0k plus d1k z to the power minus 1 plus d2k z to the power minus 2. You assume some values of these coefficients, okay, to start with, then find out from the given specification H desired minus H that you are using for improving in successive iterations. So, I will just write H e to the power j omega squared summated over the entire frequency range. So, you take omega 0, omega 1, omega 2, omega 3, some discrete frequencies. Obviously, this is a continuous function, integration of this is quite involved. So, you do it by discrete mode, all right. Suppose this is the filter to be realized. Filter to be realized need not be necessarily a low pass filter or a high pass filter, a conventional filter. It can have any desired characteristics. I want to realize this filter. Okay. So, this is the characteristics of HD given. What should be my quadratic forms? Suppose I start off with one biquad. I may have two such biquads, all right. We associate some initial values to start with all these coefficients. If there are 2, then 6 plus 6, 12 coefficients are to be given some initial values, and then you change one at a time, change C naught k to some change it by some positive value, then again compute the error, all right. We take discrete frequencies like this, all right, calculate the magnitude that is evaluated from here and the given magnitude. Okay. So, the difference square it and keep on adding, all right. Say this integral is I, okay. It is basically integration, we are doing it by discrete summation. Then change this and see what is the change in I. If it is reducing, go in that direction, again change in the same direction. If you find it is increasing, then go backward. So, it is like a grid search. In 2 dimension it looks like this. Suppose there are 2 parameters C0 and C1. Okay. So, what I am doing is, first you keep on taking some values, then increase it. Is the value of I changing? Is it reducing? then go further. Is it increasing, then come back, take midway, alright. So, wherever you get the minimum point you stop there in 1 or 2 iterations, then you change C1, wherever you get the minimum you come there, again change C1 C0, then again change C1. So, you keep on changing one particular parameter at a time. Okay. So, here you change first C0k, then C1k, then C2k, then D0k, then D1k, then D2k, again come back to this. So, in an iterative fashion you keep on doing it. So, you will get the minimum and you get the set of values. So, this is a very simple technique, and this is quite often adopted in many other optimization methods, that is you take one parameter at a time. So, basically what we are trying to achieve is the performance index, its sensitivity with respect to del C I k equal to 0 equal to d I k, all case, for all case and all i's. So, this is one method of computer aided design. Okay. Next time we will take up the other methods. Thank you very much.